piano has nothing to do with anything, but I just wanted to forewarn you that you're never going to look at cleaning your room the same way again after this video. So, all of you are probably getting sick of, talking about math and equations and the different things we can do with them and stuff like that. For those of you that aren't tired of math, thanks! But I have an analogy for you guys, and follow along with me and see if you can track, because I think this really gets the idea of why we solve an equation and how we solve an equation into really good perspective. So let's say that you're trying to figure out where something is. Let's say you're trying to find your screwdriver between two different rooms. I have two rooms here, I have one here that I'm in now, and I have one that's behind you guys. Let's say that I'm looking for a screwdriver in that room. Well, first thing I'm going to do is I like to be able to walk when I clean. So I'm going to pick everything off the floor that isn't supposed to be on the floor, and I'm going to put it into boxes. So once I do that, I have everything off the floor, I can work, I have a space I can do stuff in. Now I'm going to go through and organize those boxes. I'm going to take things out of one box, put them in another. I'm going to, get them in the correct rooms even, because, my guitar shouldn't be in the room behind you guys, and they should be in the room that I'm in now. So I'm going to move stuff where it needs to go. Next thing I'm going to do is I'm going to go through those boxes, and I'm going to determine, what isn't the thing I'm looking for. What isn't, say, that screwdriver that I'm looking for? Well, guitar isn't a screwdriver, so I put it in this room. A couch isn't a screwdriver. I'm going to leave it in that room, but mentally I'm putting it in this room because it's not the screwdriver that I'm looking for. After all that's said and done, after I've combined everything together, moved it on over to, into one room that is the not screwdriver room, I'm left with this box. I'm left with a singular box of things that my screwdriver has to be in this box. And if it's not, then I really don't know where it is, but we're going to assume it's in this box. So I go and I start going through this box. I take out everything that isn't in this box. So I have my bubble wrap, and I have my candy and my stickers, and I have a couple different cords, and I found my screwdriver. I found what I'm looking for. I've isolated it from the rest of my things to figure out where this screwdriver was. That's kind of how equations are. We're taking all these steps, all these different processes in order to isolate that variable and figure out what it is. We go through and we pick everything off the floor. We put everything into boxes. We're distributing whatever terms are on the outside of those parentheses, and we're putting them into boxes inside of those parentheses. Next thing we're going to do, now that everything is in boxes, is put those different types of terms, your variable terms and your constant terms, and put them in different rooms. Divide them by categories. Next thing we're going to do is combine those things together. We're going to put all of the terms that have variables, we're going to put them together. Then we're going to put all of our constant terms together and get one big or small constant. Last thing we're going to do is, now that we have all the variables together and all the constants together and combined, is we're going to get rid of the constants that are attached to that variable. We're going to isolate that variable. And usually we do this by multiplying or dividing. So we move all that stuff over to the other side, into that other room, and we have our variable, and we have what it equals. We have found our screwdriver. Now that I've given you that visual, let's take a look at some examples of having variables on both sides of the equal sign. When we're talking about equations with variables on both sides, we're talking about something that looks like this. Here we have the equation 7x plus 5 equals 6x plus 2. Now, we need to solve for x, but in order to do that, we need to move some things around. What I like to do is I like to get all my variables on this side. on the left side here, and I like to get all my constants on the other side. So my 5 and my 2 will be on the right side. Then I have my terms separated by type, and I can solve for that x variable. So why don't I do that? And I'll do it in a few different steps. If I want all my variables on the left side, I'm going to subtract 6x. So I'm going to do that just to write it out. I have 7x plus 5 minus 6x equals 2. Because we took that 6x away from both sides, moved it over. Now I'm going to move, and I have all my variables on one side, so I'm going to move my constant. Now the only thing that's left is this 5, and I need to put it with this 2. So if I want to undo a positive 5, I have to subtract 5. And I'm going to do that from both sides. When I do that, I keep my 7x minus my 6x equals, and for right now we'll write it out, 2 minus 5. Now I can combine these. So 7x minus 6x would get us just regular x, just normal x, and 2 minus 5 would get us -3. So that's what we're working with here. The general idea of combining or of having variables on either side is to get the sides to be the same type. So you want all your variables over here, all your constants over here, and then you can solve for x, or for whatever variable you get. So why don't you guys take a look at this one? We have 6x minus 2 equals -3x plus 7. Go ahead, pause the video, work this out, and come back when you're ready. So I have the equation here, 6x minus 2 equals -3x plus 7. First thing I'm going to do is I'm going to get all of my variables, or all of my terms, to each respective side. First thing I'm going to move are my variable terms. Now if I want all my variables on the left side, I have a -3x here. To undo a -3x or a -3x, I have to add 3x to both sides. When I do that, I get 6x minus 2 plus 3x equals, what do we have left? 7. Now I'm going to move my constants. The only constant that I have left on this side is this -2 here. So if I want to undo a -2, I'm going to add 2 to both sides. When I do that, I get 6x plus 3x equals 7 plus 2. Now I can combine my terms together. So I have 6x plus 3x. Well, that would be 9x, because we add the coefficients and keep that same variable. And we have 7 plus 2, which would also be 9. Now I can divide by this coefficient here to get x by itself. Your 9's will cancel, end up with x equals 9 divided by 9, which is also equal to 1. This equation here kind of encompasses everything that we've done so far, at least in the equation section of what we're doing. We have 3 times the quantity, 1 minus 3x, equals 2 times the quantity, -4x plus 7. There's a lot going on here. There's a lot to unpack, so let's go ahead and work through this. First thing I'm going to do is I'm going to distribute my 3 into my 2. When I do that, I get 3 times 1, which would be 3, and 3 times negative 3x. Since we have a negative 3, we multiply them together, we get negative 9, and we keep that variable. Next thing I'm going to do is distribute this 2. When I take 2 times negative 4x, I multiply my coefficients, which would be 2 and negative 4, and get negative 8, keep my variable. Then I have 2 times positive 7. Well, 2 times positive 7 is simply just positive 14. Now, I have an equation that looks like the ones we were doing before. So, let's move things to the different sides that they need to be on. If I move my variable terms first, I have my negative 9x on the left side already. So I'm going to move this negative 8x. In order to undo a negative 8x, I have to add an 8x to both sides. So I'll end up with 3 minus 9x plus 8x equals, what do we have left? 14. Now, I need to move my constants. Now, there's only one constant on here that isn't with the other constant. I have a positive 3. So if I'm going to undo a positive 3, I have to subtract 3 from both sides. When I do that, these are going to cancel, but we end up with negative 9x plus 8x equals 14 minus 3. Now, I can put these together. So, if I have negative 9x plus 8x, I get a negative x because we're adding one less than the negative here. And then 14 minus 3 would be 11. But that variable is still negative. So we have to divide or multiply, either or, by negative 1. When I do that, if I move everything over here, I end up with, our negatives are going to cancel. So you end up with x equals 11 divided by negative 1 would be negative 11. Now, let's recap what we just did here. We started out with this really long equation. This one that required you to distribute on both sides. So, we did that. When we distributed, we got 3 minus 9x equals negative 8x plus 14. Then, we moved our terms around so that we had all the variables on the left side and all the constants on the right side, and then we combined our like terms. So, negative 9x plus 8x would equal negative x, and 14 minus 3 would be 11. Then our variable was still negative, so we divided by negative 1 to change the sign, and we divided by negative 1 on both sides. So we had x equals negative 11. This kind of equation really encompasses everything that we've done up until now as far as equations is concerned. I'm not going to make you do another one in this video, but just keep in mind, keep track of what you're doing on each side. Sometimes you're going to have to distribute on both. Sometimes you're going to have to collect like terms on some and not others. But the important part is that you're keeping track of what you're doing. Because ultimately, you want to get it down to, variables on one side, number on another side, or constants on another side. That way you can find out what x equals. And that's what this boils down to. Now that we've looked at some examples of solving equations that had variables on both sides, let's put everything together and recap what we've done for the past few days. We started off with two-step equations. We would add or subtract to get the constants on the same side, and then we would multiply or divide to get that variable by itself so there was nothing attached to that variable. After that, we added the step of combining like terms. So we had multiple instances of whether it's the same variable or more constants, and we put those together so that we got a two-step equation again, and then we would do the same thing. We would add or subtract and then multiply or divide to get our variable by itself. After that, we added the distributive property. So we had terms on the outside of these parenthesis terms of these quantities, and we would distribute them into the quantities by multiplication, getting rid of the parentheses. Then we would combine our like terms, and we would solve it like a two-step equation yet again. After that, today, we added variables on both sides of the equal sign. So we had variable terms over here, variable terms over here. Whether we needed to distribute or not was another question, but once we got them all so that they were terms we could add or subtract across the equal sign, we would do that. We'd get all the variables on one side, all of our constants on the other side, and then we would combine them down, divide out or multiply out whatever numbers were attached to the variable, and we would find out what that variable is. We have isolated that variable to figure out what it is. So that's what we've accomplished over the past few days, and I think we've done quite a lot. Tomorrow, we're going to start looking at slope again, how to find it, what we can do with it, what it means, different things like that. But until then, you've been the students, I've been the teacher. I'll see you guys tomorrow.